Hey guys, welcome to Bizotech. In our last video, we discussed about concepts on clocks. In this video, we will be solving problems on the same. So let's begin with the first problem. Find the angle between the hour hand and the minute hand of a clock when the time is 3:25. So before solving all these problems, it's always better when you know the concepts in a well-defined manner. Every time when you see a problem on clock, you have to imagine a clock. So now let's take, this is a clock which is showing some 3 a.m. or p.m. So now in this clock, so you know that the clock complete angle will be 360 degree, which is divided into 12 parts. So which mean that for every space or every time when a minute hand covers 5 minutes, it will be going and covering 30 degrees, because 12 threes are again 360, so it's verified. So every 5 minutes it will be covering 30 degree. So for every 1 minute space, how much it will be covering? It will be covering 6 degree, which is 30 by 5. And the same way, just like a minute hand moves, the hour hand will also be moving. So which means that, so in 360 parts, 60 minutes and into 12 hours, so which will give you 1 by 2 degree or 0.5 degree. So that means for every 1 minute, the minute hand will cover 6 degree, and for every one space, the hour hand will cover 1 by 2 or 0.5 degree. So this is the basic thing that you need to know. And now for this question, you have different options. So with this, let's begin the solution part. So here what you need to do is, so you know that in order to find out the angle between the ants at 3 and 5, so minute hand will be at 5, which means 325. So now you could have easily told it would be 60 degree if the R hand was not moving. So R hand is also moving. So how much distance by it will be moved? So that we will be calculating here. So 25 spaces. So the minute hand will be moving 30 spaces or 30 degree divided by 60, which will give us 12.5. You can calculate this way, or for one space, the R hand will be moving 1 by 2. For 25 space, the R hand will be moving how much? 12.5. Simple. So now my subtract this 12.5 at 60 degree, because you know that this angle will be 60 degree, but you have to subtract 12.5 because our hand is also moving, which will give us the angle as 47.5. That will be your right answer, 47.5 degree. So this is a way of solving it in a manual method. And someone who hates all these things, so who hates this procedural thing, so there is a shortcut for them. So there is a formula in order to calculate the angle between r and minute hand, which is 11 by 2m minus 30h. In m place you have to substitute the given minutes in r and given r. So that will give you 11 by 2 into 25 minus 30 into 3, and on calculation 137.5 minus 90, which will give you 47.5 degree. So you will right away get the answer. Anyways, the choice is always yours. So you will decide whether you have to remember formula or you have to solve problems in a logical way. Now let's move on to question number 2. At what time between 5:30 and 6 will the hands of a clock be at right angles? And you have different options for this. And now with the last problem itself, you know that the hands of a clock will be right angle when they are 50-minute spaces apart. So this is a hint. So with this, we'll look at the solution. At 5 o'clock, the hands are 25 minutes apart. So I told you every time you have to imagine a clock. So at 5 o'clock, there will be 25 minute spaces apart. To be at right angles, we know that That too between 5:30 and 6, the minute hand has to gain 15 minute spaces. So which is total 40 minute spaces the minute hand has to gain. And in the concept part, I explained you that in every hour, a minute hand will be gaining 55 minute spaces. So if it's 55 minute spaces for 60 minutes, what will be the minute spaces for 40 minutes? So cross multiplication, 60 by 55 into 40, you will get 43 7 by 11. So how to do that calculation? So 60 by 55, so it will go in 12, it will go in 11, and then you have 40 here. And now if you multiply both of them, you will get 480 by 11, and then 11, if you divide, it will be 11 7 by 11. So 43 7 by 11 will be the right answer. So 11 ones are 11 fours are, you'll have 44 which will exceed. So 43 7 by 11. So that will be the right answer, option B. I hope this is clear. So let's move on to question number 3. How many times do the hands of a clock coincide in a day? So all these kind of questions you have to just say the answer right away. So anyways, so let's look into options. I had explained you, I had given you this in the concept thing. So the solution is very simple. So they will coincide 11 times in 12 hours, because between 11 and 1 hour they'll coincide only one time, which is at 12 o'clock. So for 11 times in 12 hours, it will be 22 times for one day, or 24 hours. So your answer will be answer option C, 22. And now let's move on to question number 4. A watch which gains uniformly is 2 minutes slow at noon on Monday and is 4 minutes 48 seconds fast at 2 p.m. on the following Monday. When was it correct? So before solving this, I'll just give you a casual example. Today, if my watch is 2 minutes slow, and then the next day, if my watch is showing, let's say it should be showing 12 o'clock now, but it's showing 11 minutes 58, 2 minutes slow, and the next day it's showing 12 minutes 12 hour 2 minutes. So now what will be the difference? The difference will not be 2 minutes, it will be 4 minutes, because in order to correct the timings, it has gained my 2 minutes and then it has went 2 minutes faster. So this is a basic key which will help you to solve these kind of problems. So now let's look into solution part. Time from 12 p.m. on Monday to 2 p.m. on following Monday, because in the question they have mentioned 12 noon. So 12 p.m. to next Monday 2 p.m. Calculate the total number of timings. So 7 days a week plus 2 hours, because 12 to 2 it will be extra 2 hours. So 170 hours. And then what is this? The watch gains 2 minutes, it was low, and then it has gained 4 into 4 by 5. What is this 4 into 4 by 5? It's nothing but 48 seconds. So 2 plus 4 into 4 by 5, and when you convert, it will be 34 by 5 minute in 170 hours. So now cross multiplication again. If it's gaining 34 by 5 minute in 170 hours, so then how much will it gain? So now 34 by 5 minute is gained in 170 hours. 2 minutes are gained in, multiply this with 2 hours. So which will give you, the watch will be correct 2 days 2 hours after 12 p.m. on Monday. So that is, add 2 days which will give you Wednesday, 2 hours to 12 p.m. which will give you 2 p.m. on Wednesday. So that will be your right answer. Now let's move on to the last problem of this video, question number 5. An accurate clock shows 2 o'clock in the morning. Through how many degrees will the hour hand rotate when the clock shows 9 o'clock in the evening? So it's a proper clock which is showing 2 o'clock in the morning. So now they have asked what is the rotation that this guy, so our hand would have took when it's showing 9 in the evening. So now when it has to come to evening, it has to come here. So which is after taking a round. So from here to here, so it will complete one round. And I had told you that one for every minute space an hour and will move for half a degree. So for one complete rotation for 12, how many degrees it would have moved? So you have to calculate that. So in order to calculate, we'll look at the options. So options is given. So let's move on to solutions. We know that the angle traced by the R and in 1 hour is 30 degree, and for 1 minute space it will be half a degree. So the total angle traced by the R and in 19 hours from 2 a.m. to 2 a.m. 2 a.m. to 2 p.m. it will be 12 plus 2 to 9 it will be 7, which is 12 plus 7 19. 30 into 19 will be 570 degree, and that will give you the right answer option D, 570 degree. So that's how the problem works in clocks. So in our next video we will see more of this kind. Thank you so much for watching.